Welcome to session 4. So, as Diane mentioned today, the topic is how to support voice using circuit switch fallback, and we'll also learn about SRVCC, single radio, voice call continuity. Yesterday we talked about how to support voice using IMS network. And today we look at some additional mechanisms. Briefly, my background, hopefully you already know that, but in case you are tuning in for the first time, I have a degree in electrical engineering from Virginia Tech. I have worked for Nortel and Huawei on ICE95 1X UMTS, EVDO, and for more than 7 years I have been teaching various technologies, LT, WiMAX, etc. Okay, before we get into the material.
Hello?
Hello?
Hello. I couldn't access the live meeting. Can someone send a...
This is Diane Easter. If you could email me your name.
Sure.
I'm Diane.Easter, and I'll help you.
Okay, thank you.
Sure.
Anyone else who needs help? Okay. Yeah, so if you could please let me know the type of work that you are currently doing. Okay. Looks like we are gradually getting more and more participants, but about 30% system test integration, about 30 to 40 customer support, systems engineering. Okay, very good. Let's see what kind of details you prefer. Okay, so looks like 70-30. Okay, 70% medium degree of details, 30% lots of details. Okay. Our sessions are geared toward medium degree of details, and we rely upon you to ask questions whenever you want more details. So please maximize the use of Q&A box, and I will also give you opportunities to use the audio bridge periodically. Okay, so this is what we have planned for today's session. We would summarize various ways of supporting voice in an LTE network. We have one approach, so-called CS fallback, circuit switch fallback. So we will discuss details of that. Basically, we can use legacy, second generation, and third generation systems for a voice call. There is a vision called ISC, IMS Service Continuity. So as we go from one radio access technology to another radio access technology, we would be able to maintain the service, continue the service. So we would talk about that concept. And one specific case of this IMS service continuity is voice. So we would like to continue the voice call as we go from one technology to another. So think of voice as a special service, one of the services. Okay. And we would talk about SRVCC, single radio voice call continuity. So we have a single radio UE. So the UE can be either on one technology or the other technology. So at a time, it is either on LTE or some other non-LTE technology. So if the UE moves outside the LTE coverage area, then we have to do the handover to a legacy technology. So that's the SRVCC feature. So we would talk about that feature. So CS fallback, SRVCC, those are the two main concepts. But along with that, we will also talk about some other topics as shown here. Okay, so first, high-level view of how to support voice. So here we have mentioned all possible ways that we could support voice. First and foremost, we have voice over LTE. This is the one we talked about yesterday. So basically here we would use the help of the IMS network, IP multimedia subsystem, to make a voice over IP call. And since IMS is very comprehensive, we want to make sure that the UE and the network can work with each other to support voice. So we have defined some minimum set of features to ensure interoperability, and that is done through so-called one voice profile. So one voice profile is basically minimum requirements, and voice over LTE is the marketing term you would come across. So once you have implemented the features recommended by one voice profile in the UE and in the network, then we are all set for a voice over IP call. A circuit switch fallback. Circuit switch fallback. To make a voice call, we are falling back to the legacy circuit switch technology. So here there is no IMS network involved. Okay. So if we want to go ahead and start using the voice services in LTE, then we do not need to wait for IMS. So for example, if you recall from yesterday's session, in the IMS world, if you want to support voice or IP call with, let's say, connectivity to PSTN, then we need several gateways. We need breakout gateway control function, we need media gateway control function, right? Media gateway. We need a lot of these kind of entities, okay, to support voice or IP. Okay. But if you do not want to invest right away in those entities, then we can just use the legacy technology, and in that case we buy some time before we invest in those specific components to interwork with PSTN. So that is the idea here, that we can save some money initially and prepare for future voice or IP IMS based solution. So in the meantime, our subscribers can still get voice services, but it would be through legacy net technology. So 2G, 3G does not matter. So we can even have GSM, or we can have UMTS or 1X. Either way, we do not worry too much about exact generation. We support both technologies, second and third generation. Now there is one more approach. We would not pay too much attention, but there is something called Volga. Similar to CS fallback, even Volga does not need IMS. Again, we will save money initially. And the idea here is that we will use the LTE radio network. So it's voice over LTE using generic access. So it could be any kind of access, but you would be basically using some interface, some kind of Volga controller. Here is the UE, then we use the LTE network, and then it will use legacy technology. So we just do the translation between the LTE messages and legacy circuit switch messages, so that we can do call setup and use legacy CS code to access PSTN and other CS services. Now, that one again reuses the existing infrastructure, but since we already have fully defined circuit switch fallback and another approach, SRVCC, there is not much interest any longer in Volga because the standard is very well defined in terms of CS fallback and SRVCC. So there is not much interest. There may be few pockets around the globe here and there. I have heard a couple of deployments in Europe, but for most part, you can safely assume that voice over LTE, CS fallback, and SRVCC, those would be the mainstream approaches to support voice. SRVCC, basically, if we are in LTE radio coverage area, we would use LTE technology. If we move outside the LTE technology, then we will do the handover. Now, in that case, we do have IMS network. Our caller is anchored at the IMS network. So IMS network knows whether we are in the LTE coverage area or we are in the legacy CS coverage area. And we can do the handover from LTE to legacy technology. In the initial version of SRVCC, we have one-way handover. One-way handover. From LTE to legacy technology is one way, unit direction, like one-way street. Once you go to legacy technology, you finish up your voice call and then you can go back to LTE. So that is the initial version of SRVCC, that if you are in LTE coverage area, use voice over IP. If you leave LTE coverage area, then use legacy circuit switch call, and IMS will help us do that kind of handover. So it is handover. The vision that we have, and that may take several years to realize, we have so-called ISC, IMS service continuity. So the idea is that you can go back and forth between any technologies, and you can support voice and many, many other services. Not only that, maybe for voice we would use legacy circuit switch technology. At the same time, we would use LTE for packet switch services. So in that case, we may even have dual technology UEs. They support two technologies simultaneously. So we have two radios, two transceivers. Even that is supported by that vision of ISC. So that is sort of a little more futuristic. It would take a few years before we can get there. But in the meantime, at least we have a very solid voice over IP solution. We have circuit switch technology for CS fallback, and we have SRVCC for the handover. So those are basically the main solutions that we would rely upon in the coming years. Little later, we would have ISC. It looks like we have some question. Okay. Now, we have one comment. How about using Skype over LTE? So, good question. Let me draw some picture. Very good question. Now, initial deployment of LTE that we are experiencing now, we have no voice support. It's basically data cards, right? We have data cards that we insert in the laptops, that kind of solution. So that UE, this is our UE data card, and we have the EPS, let's say PGW here, internet. Now, we have the solutions of voice over LTE, where we have IMS network that is talking to the PGW. So voice over LTE is standardized solution. So when we make a voice over IP call, this is the real handset. So next year we should have wide availability of those UEs. Now in that case, SIP signaling messages, they really find their way to the IMS network. Now in that case, the operator is aware of that. So it is operator controlled because it is through IMS, voice over IP. So in that case, we have the proxy, we have PCRF, we have enforcement function, PGW, right? We have all those interactions, and we can provide quality of service. Okay. QCI number 1. Remember, we have 9 levels of quality of service. QCI 1, we can have data rate guarantees because we are following one voice profile, and this is the speech model. So if you have this standardized solution, voice over LTE, then we can really guarantee this kind of QoS. Now, if you go to Skype, then what happens? So that we can do even today. So we have this, let's say, UE data card. We talk to the radio and the core network, and here is the PGW, is internet, maybe some Skype servers. Now, in this case, what would happen is we would be using default EPS bearer. On the default EPS bearer, we are seeing email, web browsing, we are seeing now the Skype, Yahoo type, voice over IP. So they are all treated in the same way. And the QCI that is allocated to this default bearer is 8 or 9. And remember, this is a non-guaranteed bit rate. So now, when you make a voice over IP call using Skype, Yahoo, your quality of service would now suffer, okay? Because there is no data rate guarantee. So if the network is not loaded much, if you are one of the early UEs, then you are okay. Then the scheduler will hopefully give you some resources. However, when there are other high priority UEs or UEs that are doing some QoS sensitive applications, then you will get a lower priority. So it's possible that for many milliseconds, even seconds, you may not have any resources. So then your voice quality will suffer. So you could do voice over IP today using Skype, Yahoo over LTE, but there is no guarantee of quality of service. So that would be the main difference between the Skype, Yahoo type voice over IP and operator control Verizon, AT&T type voice over IP. That is the key difference. We have QoS guarantee and we have no QoS guarantee. That is the main difference. Okay. Now, it looks like we have one additional question. Oh, so now we have another idea. So, and the suggestion is that how about use Skype and give that QCI 1. Okay, now remember, there are always ways to have a proprietary solution. Okay? You can always do your proprietary voice or IP solution. Okay. However, the problem is the cost and scalability. Okay? Voice or IP, just one simple example. Now you have to figure out exactly how will you do QCI 1, right? Because remember, in the standardized solution, the PCRF is deciding the QCI. So now you need to figure out a way to somehow tell PCRF that this is a voice or IP call from Skype. So you need some extra processing which is proprietary. So you could do that. You could have some proprietary box sitting maybe inside the PGW perhaps, and we are doing deep packet inspection and checking is this Skype connection, is it voice or IP type call. Then you can contact the PCRF through some proprietary way, but that's all non-standardized solution. So it is possible to do what you are saying, but it would be a lot of proprietary work that you need to do. Because the standardized solution is extremely clean, right? We have open interfaces, the SIP signaling message find its way to the proxy, call session control function, the message goes over standardized interface RX to the PCRF standardized interface GX, it goes to the PGW, PCEF. So now we are breaking all those standardized interfaces. So that would be the problem. It is possible, but the only problem is there will be a lot of proprietary work that would need to be done. And QCI is applicable to the bearer, that is correct. Bearer. So if you want to have two applications with two different QoS requirements, you need to put those two applications onto two different EPS bearers. So as Bill has correctly pointed out, a QCI is for bearer. Then you would need different bearers for different applications when those applications need different QoS. In LTE, we control QoS at the bearer level. So thanks for your question and your additional comments. And we are looking at IMS as a long-term solution to the services problem. We want to use IMS as the services framework. So voice or IP is maybe the initial killer application, so to speak. But in future, we can start offering a variety of services. So even today, we are deploying IMS for SMS, presence, and then you can have location-based services, things like that. Imagine any service, you can develop an application server. Put that application server in your IMS network, and millions of your subscribers can access that application immediately. So IMS is a rapid deployment of services. And hopefully, over time, you would recover the cost. And again, you have to just upgrade your software in a single location in the application server. Okay, it's very, very easy to deploy services. And in today's world, if circuit switch world, right, if you have services attached to the MSC, you have to upgrade your many MSCs to give your subscribers access to those services. But now, if you have IMS, you upgrade the software at one location and you are all set. So the hope is that this kind of centralized service solution would help reduce the cost in the long run. And we are using all the standardized interfaces. So the operators can do mix and match. They can buy CSCF from one vendor. They can buy application server, another vendor. They can buy media gateway control function, another vendor. So they can get a lot of benefits out of that as well. Okay, let's go back to our PowerPoint slides, and thank you for your questions. So that is basically the set of mechanisms, different approaches available to support voice. Okay, just very briefly, motivation for each of those approaches. Yesterday we talked about this voice over LTE solution. So in that case, we have this IMS network. At the brain of the IMS network is call session control function. Right? And when the user makes a voice or IP call, SIP signaling would be finding its way to the proxy. We would involve some kind of application server so that we can provide additional features, three-way call forwarding, things like that. But if you're talking to PSTN, then we will be going out of the IP domain, breakout gateway control function, media gateway control function, SIP signaling converted into ISUP signaling. So the call setup is done. Once the call setup is done, the voice over IP packets are traveling like that, PGW to the media gateway. That's all voice over IP. And then we have a trunk, 64 kilobits per second signal here. That is the way we can support voice. If it is a call to another UE or an IP phone, then much simpler, no need to go outside the IP domain. So in that case, we have packets going like this all the way up to PGW. And from PGW directly to the outside world, the internet, and to this IP phone. Okay, so that's how we use IMS network. IMS is for call setup signaling. Once the call is set up, the media can flow directly between two endpoints, two UEs, for example, and that's through the IP. So now we stay in the IP domain, IP to IP call. And the specific approach that we mentioned was voice over LTE. So we wanted to simplify and we wanted to make sure that we have interoperability and we have minimum features. So what to use for authentication, IMS specific approach for authentication, we will use specific speech codec. So as I mentioned yesterday, the only codec we are supporting now is adaptive multi-rate. So in today's 1X networks, we use EVRC codec. But now the new UEs, LTE UE, those handsets would be supporting AMR speech codec. So for a voice or IP call in LTE, we would indeed be using AMR speech codec. We want to make sure we are using the resources efficiently. So in that case, reducing the size of the headers is very, very important. So we would use robust header compression. More specifically, PDCP layer would be doing the IP header compression. We can support both IPv4 and IPv6. Circuit switch fallback, the motivation here is that let's say we do not have the IMS network that is ready for voice. Now in that case, what we can do is when we are in the specific geographic area where EUTRAN and legacy technology both available. Okay. So at this location, we have EUTRAN coverage and we have legacy technology coverage. So both technologies are overlapping. So if UE wants, UE can talk to LTE, radio access technology. If UE wants, you can talk to legacy technology, could be 1X or UMTS, or for that matter, GSM, GPRS, Edge. That is the requirement. The coverage must overlap. Okay, you have to have both technologies, LT and non-LT, available at that location. Now what happens? If you are doing the regular packet switch services, for example, video streaming or web browsing, etc., then we will be using LTE EU trans. If we want to make a voice call or someone tries to reach us, it's a mobile terminated call. So in that case, we would leave LTE and then set up the call in legacy technology, circuit switch technology. And once the call is over, come back to LTE. Those would be the main steps. So for a voice call, we go away from LTE, we disappear from LTE. But we do tell the network that, oh, now the UE is going away, so that we do not send packets with the UE. UE is no longer on LTE air interface because the UE is talking with the legacy technology. But once the voice call is over, then we can come back to LTE. Now, when we go away from LTE to make a voice call, to receive a voice call, then what happens to our data? Okay. Because maybe we were doing some web browsing, email or video streaming. So what happens to that? So there are two possibilities, and both are supported by the standard. So either we do packet switch handover. So we move our data to legacy technology. So when you go from LT to UMTS, then your voice goes to UMTS and your data also goes to UMTS. So you do the handover. Or you can suspend data in LTE. So it means that our bearers, default, some dedicated, they become dormant. So no more data transfer. So they become dormant. We do not completely eliminate them. We store the information about those bearers in memory within the network. And we take care of the voice call. Once the voice call is over, then we come back to LTE and resume data in LTE. So as long as your voice call is on, there is no data transfer because we have suspended data transfer in LTE. So those are the two possibilities, and from the standards perspective, both are supported. Currently, vendors are able to do only two, so no handover initially. But my understanding is that in the coming months, the other approach would be becoming available as well. But right now, there is no packet switch handover supported, but it should be available in the coming months. If you have any update, just let me know. But that's my understanding. Okay, now there is one question. Oh, will the session be timing out? Actually, we are putting the data in dormant mode. Okay, so it means that information about the bearers is stored inside the network, but there is no radio bearer or S1 user plane or S5. We just put those bearers in the suspended state. So no real data transfer is occurring, but we just know that we have in the past established these kind of bearers with these kind of QCIs. So in future, when the UE comes back to LT, we can quickly say, oh, bearer number 5 and 6, let's reactivate, let's resume data. So it will result in faster data resumption when we come back to LT. So there is no timeout because we have already suspended the data. So no more data transfer occurring. We have suspended that. So there is no additional timeout. Now, there is a question on dual receiver UE. Now, here is the problem. If you want to have simultaneous voice and data, because that's your basic question, that can we have voice call on CS and data on LT? Yes, it is possible if the UE has dual transceiver, meaning transmitter and receiver. You cannot have just a dual receiver and have data sessions ongoing on data along with your voice call. Now, it's possible that in future, we may have those dual transceiver UEs, meaning you have one transmitter receiver for 1X, a separate transmitter receiver for LT. So then our UE can be on two technologies exactly at the same time. Then it is okay. Then you can do voice on 1X or UMTS and data on LT. So that is done if the UE is capable of supporting two technologies simultaneously. Here we are assuming that initial UEs would be low-cost UEs, and there is only one radio, so one transmitter, one receiver. So that transmitter-receiver transceiver, either it is on one technology or on another technology. That's why we say that you have to suspend data if you cannot do packet switch handover. But yes, it is possible if you have dual transceiver UE, then it's possible. Now, if you have guaranteed bit rate, what do we do? Excellent question. So, guaranteed bit rate, we have to release those bearers. We cannot have them in suspended state because, as the name says, right, guaranteed bit rate. So, if there is a bearer, we have to guarantee the data rate. And those bearers, unfortunately, we have to release them. We cannot put them in suspended state because they are of guaranteed bit rate kind. Good question. And one more question. How is the voice call recognized? Oh, sure. Do not worry. We have call signaling flow coming up. So you will get a lot of details. Right now, I'm just giving you high-level concept, the motivation and the basic idea, but I will give you signaling flow. Okay? So do not worry about that. Just wait for your answer. Now, who decides to suspend data? Network, not the UE, but the network. The network decides based on UE capabilities. Normally, in UMTS and LT technologies, network is in control for most part. So the network would decide, more specifically MME, would decide based on UE capabilities that yes, we should do the suspension of bearers. We have one more question in the pipeline. Oh, so the comment is, if we already have the capability of doing the handover to another technology, you have dual transceiver anyway. Oh, so let me draw a picture. That should clarify some of the things we have been discussing. Okay, so if you look at transceiver architecture, transmitter plus receiver, Then there are two main parts. We have baseband processing and we have RF processing. So this is the chipset, baseband chipset. Okay. So when I say we have single radio, what I mean by that is we have one RF processing block that is shared between multiple baseband blocks. So I would have, let's say, hybrid UE, LTE, non-LTE UE. So this UE has LTE baseband. I have non-LTE baseband, 1X, 1XC video, UMTS. But they share the same RF process. And here we tune to a specific frequency, carrier frequency. So as an example, if we are talking to LTE technology, we look at 700 megahertz. And if you are talking to UMTS, EVDO, whatever, it may be 850 or 900, 1900 megahertz for another technology, legacy 2G, 3G technology. So at any given time, our RF processing is tuned to only one carrier frequency. This is what would be the most common low-cost UE. Okay. So it means that even though the UE is capable of working on any technology, then the UE is at any given instant, either it is on 700 megahertz LT or 850, 900, 1900 megahertz for non-LT. So one at a time. If we have two receivers, two transceivers, so this would be higher cost, UE. Okay. So in that case, we have baseband processing for LTE. We have RF for LTE. And then we have baseband processing for non-LTE and RF for non-LTE. We have separate blocks. So then you can have simultaneous communication on multiple technologies. So that is possible, but it will be more expensive. So that's why initially we will not see this kind of UEs that have both baseband processing and RF processing for multiple technologies. It will come, but it will take some time. Okay, and there is one additional question we got. It's suspension of barriers, because UE can look at 3G and 4G. So yes, short answer is yes. UE could be getting handover directives. Yes. So we can send a hard handover command to the UE. That is correct. So you can, if you are on LT, you can ask UE to go to another technology. I will show you a call flow. Okay. But for now, assume the following. Okay. That if, let's say, if there is no dual transceiver UE, then packet switch handover to 3G. So this is supported. Or no handover. So then only in that case EPS bearers are dormant. That's it. So just keep that in mind for now. Okay, and I will show you a call flow later. Okay, that will make things clear. So those are the two options that we have. So thank you for your questions. Oh, looks like we have some more. Okay, UE does not request handover to another technology. Only the network will tell UE that go to this technology, go to that technology. So network gives the instruction. UE can never make a request for handover. Okay? UE cannot say, oh, I want to go to this technology. Only the network gets the measurements. Okay, network instructs UE to make measurements, and based on UE measurements, network makes the handover decision. So in terms of handover request, UE doesn't really have sort of control. Network has the control. Can you have one RF block and when we are on voice 850 and on data you'll be 700? Is this a cheap handset solution? But again, whenever you have two carrier frequencies, you need two frequency oscillators. You need two separate RF processing blocks. You have amplifier, you have filters, low noise amplifier, lot of things are there. You have duplexers. So you still need to either have two separate RF processing blocks or share it just like what I showed earlier. So those are the only things we can do. Okay. So either you share, then it is low cost, or you have dedicated RF processing blocks, and that basically increases the cost. So the configuration you are mentioning, that is what we would do initially, and that we have one RF processing block. So when you are on a voice call, you will be, let's say, on 850. Our RF is tuned to 850, and when we are on data, LTE, then we'll be on 700. So RF is tuned to 700. So that is the cheap handset solution that we have today. Okay, another good question, that when we release the GBR type bearers, then do we sort of automatically establish those or not? Now for GBR, we have to have some activation. So the UE needs to use some kind of application. So it would be treated like a new call. Okay. So again, we will have regular SIP signaling. So it is not sort of automatic. The only thing that is really automatic is dormant bearer resumption. The bearers that have been suspended. But if the bearers are not suspended, if we already release those bearers, then we need UE, the user, to do something, some data activity to trigger some application, and then it's like a new call setup, new bearer setup. Good question. Okay, another approach to support voice is SRVCC. Now, remember, this says that when we are inside the LT coverage area, then we have voice or IP through LT. And now we go outside the LT coverage area. So there is no LTE available, only CS available, legacy technology. So we have to do handover. Okay. So this SRVCC is handover. Okay. So we already had a call going on, voice or IP call. But now we leave LT coverage area, there is no LT to be found. So it means that we have to do handover. And that handover is SRVCC. Single radio, we have one transmitter, one receiver. And we are able to continue that voice call through handover. And in that case, we have to go from packet switch voice or IP to circuit switch handover. And again, we will use the help of IMS network. When we are in LTE, IMS knows that we are in LTE. When we go to legacy technology, IMS will continue acting as an anchor. So IMS will now facilitate the handover from LTE to legacy technology. But initially, it is a one-way handover from LTE to legacy technology. Okay, one way. In future, we will have bidirectional, but initially it is one-way handover from legacy technology. From LTE to legacy technology. But the main benefit here is cost. That our cost will go down because we have a single transceiver, one transmitter, one receiver. So that is very, very important. And the main benefit here is we are saving the cost, low cost and much simpler device. So I would again discuss the call flow for SRVCC as well. Okay, so time for me to ask you a question. I'll give you a couple of minutes to think about this. CS fallback, circuit switched fallback. We are falling back to the legacy circuit switch technology. And by the way, as you may already be aware, in the PDF file, for the course material, we have a list of acronyms. So feel free to consult the appendix, or you can always send me a question. Please participate in the polls. Thirty seconds to go. Okay. So about 80% correct answer. So it is a way to support voice calls in CS domain. See, as the name says, circuit switched fallback. We are falling back to legacy circuit switch technology. Remember, LT is all IP, all packet switch. There is no circuit switch core network in LT. So, when you want to make a voice call in CS fallback, you are not using LT technology. You are actually going away from LT. You are disappearing from LT and relying upon UMTS 1X GSM to support voice. So we want to use legacy technology, not avoid. And IMS is not required at all to support CS fallback. Okay? Because CS fallback, we use CS technology. That's it. IMS has no idea that we are using a legacy technology for a voice call. So no IMS is required for CS fallback. That is one of the motivating factors. So if the operators want to save money by delaying the introduction of specific components, MGCF, BGCF, etc., then they can use the CS fallback technique. Okay, let's go to the details. So first, we will talk about CS fallback. Here you will see call flow for supporting CS fallback. And once we are done with CS fallback, we will briefly talk about how to support SMS, and then we will talk about SRVCC. Okay, so first CS fallback. Okay, currently in the material that you have, we are focusing on CS fallback with UMTS GSM type technologies. Okay. And toward the end of the session, if we have time, I will summarize how that works with 1X. Okay, so let's say we have the UE that is capable of talking to multiple technologies, 3G, 2G technologies. So when we are talking to LTE technology, then we have connections between UE and MME, that is non-access datum signaling connection. The air interface could be any 2G, 3G or LTE interface. To support CS fallback, we need this special connection between MME and legacy switch, MSC or MSC server. So this is the main interface that will support interworking. So here is the idea. Let's say someone wants to reach us. So here is landline phone. Someone tries to call us. So it's a mobile terminated call. So the page message would be then sent by MSC server via this SGS interface. Right now, the UE is on LT. So the UE talks to E node B, etc. So we are on LTE air interface at this point. So we have connectivity with the MME, that is the non-access datum signaling connection. So here is the E node B. So now the page message will be finding its way, CS page, to the E node B, and then since UE is observing LTR interface, then we will get page message on LTE. So when the UE opens up some LTE message, and I will give you the exact names later, when the UE opens up some LTE message, inside that there is a page message for a voice call. Same way in the other direction. If it is mobile originated call, then using LTE, we will tell the network that I want to make a call. Okay. That the UE wants to make a call, and then that message will go to MME, and the MME will now start working on the CS fallback procedure so that UE can go to legacy technology to make a call. So the initiation, whether it is page message or request for a mobile originated call, that is done still using the help of LTE technology. So that is the idea, that UE is on LTE technology, and then either mobile originated or mobile terminated. Either way, we have communication between UE and the LTE technology so that we know that the UE is going away to legacy technology, so that we do not send any packets, because this is a single radio UE. It can only be either on LTE or a non-LTE technology. So we want to make sure we do not send packets, and we have to basically release the resources within the LTE system so that we do not waste our resources, and the UE will then make a call, or it could receive a call. But the main interface that helps us implement CS fallback is SGS. This way, an incoming call can be received by the UE. Similarly, when the UE wants to make a call, right, then MME will again work with the UE to help UE go to another technology. In general, since we are able to now talk to the MSC server, we have access to potentially other services. So for example, I will show you how we can support SMS, because SMS is a traditionally CS service. Yesterday we saw how to support SMS using IMS, and today I will show you how to use SMS through a legacy technology. So this is what would happen. Right now we are, let's say, on LTE technology. We have the bearers going this way, EPS bearer. So maybe some kind of data transfer is ongoing. In the past, the UE has registered with both LTE and legacy technology. And as part of that registration, attach operation, this MSC knows that this specific MME number X, that is in charge of the UE. So when we did the power up, in the LT coverage area. Then we did the attach operation with the LT, and at the same time, we had communication between MME and the closest MSC, who is in charge of that geographic area. So we have communication between MSC and MME. So now MSC knows that this UE with, let's say, INZY is basically taken care of by this MME number X. So that kind of information is now known by the MSC. So if someone tries to call us, then the page message can be sent to all E node Bs in that specific geographic area. And once we get the page message, we will respond by accessing the legacy technology, and that will go to the MSC. So the page message comes over LTE. This is LTE page message. So the UE is on LTE technology. So one of the LTE messages would carry the circuit switch paging message. And once the UE gets the page message, it will access legacy technology and respond to the page message through legacy technology. So page comes through LTE, but the response goes over non-LTE technology, legacy technology. Now when we do these kind of CS fallbacks, then either we can do the handover. Okay, so that is the packet switch handover. We move our bearers from LTE to legacy packet switch technology, or we just sort of drop, maybe that is too harsh a word, maybe dormant, and make the appropriate bearers dormant. So we suspend data. That's a little better term. Okay. It looks like we have some question here. What happens if MME relocation occurs? Okay. So whenever we have change in the tracking area, basically resulting in some cases in the change in MME, we will update the MSC with that. So let's say UE goes from one MME area to another MME area. So when the UE does the tracking area update, then the new MME will inform the MSC that, oh, by the way, I am the MME in charge of the UE. So the MSC will update the database to reflect the change in the MME. So good question, but no need to worry. Our new MME will be telling the MSC about the new location of the UE. So still no problem. Here are the procedures that we support for CS fallback. Okay, first of all, let's power up the device. So then we will normally do attach operation. But since this UE supports CS fallback, we have to do so-called combined attach. Combined attach means we attach with the EPS, and then we attach our INZY to some legacy technology. So combined attach means not only attaching to LT, but also attaching to another technology, let's say UMTS or 1X. So that is Actually, for 1x we use a different term. So let's say attach to the UMTS type network. Okay? IMSI attach to UMTS. Then we have possibility of either a mobile originated voice call, then it is mobile originated CS fallback, or mobile terminated. So here there is a page message involved. So either case, so if it is mobile originated CS fallback, then the UE will make a request to the network that I want to make a call. So that goes to the MME. Or if it is a page message coming from legacy technology, then MME will send a page message. So MSC to the MME and MME to the UE. So now we have to send a page message. And once the page message is sent, then the UE sends CS fallback request. So then we are back to this specific state. So basically, once the CS fallback request is made, then either we do packet switch handover and then make a voice call, or just directly make a voice call and make the bearers dormant. Suspend data. Now, in some technologies, 2G technologies, there is no real handover. There is a cell change order. So that is applicable to GPRS edge. And then we again make a regular voice call. Now we can do CS fallback either in the active mode of LTE or idle mode. So active mode means we have RRC connection, and idle mode means there is no RRC connection. The radio network has no idea about us. Only the core network knows about the UE location. So let me ask you a question. In LTE, when the UE is in the idle mode, the MME knows the UE location with what granularity? Okay. Do we know the cell number? What do we know? Where the UE is? How does the MME keep track of UE location? What do we call that location? Do we call it location area? Do we call it routing area? What do we call that geographic area? Tracking area. Excellent. Excellent. Tracking area. Very good. Thank you for your answer. And when we send a page message, we will use STIMSI to send a page message from all the E node base in that specific tracking area. Okay. So in that case, this is applicable. The page message is sent using STIMSI as the identity of the UE. Now we have got some questions. In circuit switch pre-registration, what do we need to do in the core network? Let's wait for answer to that question, because when I show you a call flow, it will become clear. But basically, the idea is that we want to minimize the impact on the existing networks. So from the existing networks perspective, Pretty much it appears like a regular call, regular registration. So, for example, MSC works with the HLR to do authentication. So that process remains the same. So we do not need to do anything special in the legacy core networks. But yes, MME in LTE, yes, it needs to do some extra work. But that will become clear when we discuss call flow. Now, if another question, when we have multiple technologies, 2G, 3G, 4G, then there are a lot of options. Then UE needs to register in multiple technologies, 2G, 3G, and 4G. Now, first of all, LTE, that has the highest priority in terms of connecting to a technology. And then if 3G is available in that area, then 3G is chosen. If 3G is not available, then 2G is chosen. So let's say we are in a specific location area. Okay. Because in circuit switch terms, the geographic area is called location area identifier, LAI. So one specific location area identifier, LAI, would be the responsibility of one specific MSC. So that MSC, if it's a 3G technology, it will be 3G MSC. If there is no 3G available, it will be 2G MSC. So the MSC that we will pick would correspond to that specific location area. And the location area would be either having 2G technology or 3G. If both are available, then 3G. So we are effectively registering with one specific MSC VLR that is in charge of that specific location area identifier. Okay, very good. Okay, one more question. You will originate voice call. When we want to originate the call, okay, then we just inform the LTE system that we are going away. So the circuit switch fallback request, let me go back to that just to make sure that we have the same understanding. See, here I am mentioning that U is on LT. So it tells the LT network that I want to make a CS call. Okay. So just informing the network that we are trying to make a voice call. The actual call origination message, that would go directly to the legacy technology. Okay. Could be 2G or 3G. So call origination occurs on 2G, 3G access. But before we go away to 2G, 3G, we should let the network know. So network does not send us packets and we need to release some resources. So hopefully it is clear. There will be some delay because it has to talk to MME first. That is correct. But hopefully it will be few milliseconds and not seconds. UMTS call setup delay several seconds anyway. So a couple of 100 milliseconds should not be a big deal. Okay. If you have any other question, just feel free to follow up with additional questions. Okay, so before we go into the call flows, let's have a short break. So we will have a 10-minute break. Okay, then let's continue, and please rely upon Q&A facility in live meeting to submit your questions. And again, if the answer is not satisfactory, you want more details, please ask follow-up questions. Okay, so now we will go into the details, specifically call flows to support CS fallback. The UE power up occurs here, and as part of the power up procedure, the UE sends attach request to the MME. Normally, if there is no CS fallback, the attach type is just the initial attach, okay, regular initial attach. However, here we have the UE capable of CS fallback, so that's why it is a combined attach, and it says EPS in the attach. So it wants to attach to the EPS network, and it wants to attach to the legacy network that is indicated by IMSI. The MME learns that, okay, this UE is capable of CS fallback, and it will first take care of LTE authentication. The bearers are being set up as part of the attach operation. And normally during the bearer setup, we also give IP address to the UE. So all those things are happening in parallel. Now, specifically to support CS fallback, we need to do some extra work. So this is what MME would do now. It would figure out that, okay, this UE is right now in tracking area number, let's say, A, and inside that tracking area, okay, and we are getting the message from a specific E node B, that's the attach request coming. So we need to map that area to specific location area. So we say, okay, TAI number A, let's have and specific E node B. So let's map that to location area number, let's say, alpha. So it derives based on that identity of the MSC or MSC server, that who is in charge of that location area. So in one very simple implementation, we may have database in the MME itself. That is one possibility. And it says if this is location area alpha, then MSC number 3 is responsible for that area. And now it will talk to MSC number 3. So it has this kind of mapping. So operator can configure this kind of mapping to figure out which MSC to talk to. So now we are sending a location update request to that MSC, and we indicate which UE we are trying to get the update for, and we indicate the identity of the MME. So let's say this is MME number 10. So now we know that this UE with a specific IMSI is the responsibility of MME number 10. So now that entry is created in the MSC database. So location area update accept. We know that, okay, we have to allocate IMSI. So this is a temporary ID. So if you recall, we want to minimize the use of original identities such as IMSI. So we are now allocating teams. In the attach accept message, normally we have GUTI present, globally unique, temporary ID for LT. So this is the identity that MME allocates to the UE for LT. Now, in addition to GUTI, if you see PIMSI and the location area identity, then the UE knows that MME has already registered me with the legacy CS technology. So if you are a UE and you do not see PIMSI, then you know that you are not registered with the legacy technology. Then you cannot use CS fallback. But if you see PIMSI, you know you are in good shape. Anytime you want to make a voice call using CS fallback, you are okay. You have a green signal for that. Okay. Now, in the meantime, between the steps 3 and 4, right, the MSC server is just informing the HSS that the UE is in a specific area. Because in the traditional circuit switch world, HSS knows about the location of the UE, right? Which VLR, which MSC is in charge of the UE. That's the location of it. But that's legacy, so nothing new. So in summary, when we do power up, we do LTE attach, and also we do attach with the legacy circuit switch technology. So in future, if someone wants to reach the UE, then the MSC can send a page message to that specific MME. That is the basic idea. Okay. Now, attach, combined attach is done. And UE wants to make a call. How do we make a call? Now, in this example, the UE wants to use CS fallback. In general, UE can use, let's say, regular voice or LTE for a voice call, and that would have higher priority. But either the UE is not capable or the network is not supporting that, then the UE will use CS fallback. And based on the combined attach, the UE knows that I'm allowed to use CS fallback. So it sends a message, extended service request. This is a non-access data message. And that message indicates CS fallback, that I want to make a call using CS fallback. So that will find its way to the MME. So that is the key message, extended service request. So for CS fallback, we would use extended service request next message, non-access data. So the destination of that message is MME. The MME will instruct the E node B that we need to do this CS fallback. We need to do a handover, and once the E node B gets the handover instruction from the MME, it will optionally, now this is optional, it will optionally ask UE to make measurements of target technology. So if we are going, let's say, from LT to UMTS or GSM, then we can ask UE to make measurements of UMTS, GSM, etc. And the reason for that is you can pick a better cell, better sector for UE to do the call origination. If you do not do any measurements, then you can just have some static configuration that if the UE is in, let's say, this E node B, is taking care of 3 LT cell, physical cell ID 0, 1, 2. Then if we are doing this processing inside PCI 0, then we can statically configure that to UMTS primary scrambling code 100. So we could have that kind of static configuration, some kind of database, or we can just ask UE to make measurements, and based on the measurement report, we can instruct the UE to go to that specific cell. So now, another optional feature is packet switch handover. So when we go to the legacy technology for a voice call, we can take our data with us, right? So that is the packet switch handover, but it is right now not supported by vendors, but the standard does support that even today. But it is optional. Either make the bearers dormant, or you can do handover, packet switch handover of your ongoing data sessions. Okay, so now we tell the UE that go to this specific primary scrambling code, right? Handover command, primary scrambling code for UMTS number 100. Then UE will go to that specific cell, and it will do the regular call setup. So now onwards, it is a regular 2G, 3G call setup. So it's a service request to the RNC. This is a 2G, 3G radio network controller, BSC or RNC, and it will work with the MSC. And then we set up the call. So the call is being set up, the UE and the 2G, 3G, BSC, RNC, and RNC and the MSC. That is the regular call. So from step 4 onwards, it is all regular call setup. And the call setup for voice is done, and then the packet switch handover is occurring next. So that will be between UE and the RNC and SGSN. So now we are moving the data from LTE to legacy technology. So it means our bearers in LTE, they have to be mapped onto PDP context in UMTS, because we need to provide quality of service. Our database would not be very high, but we will have to do such quality of service mapping. One of the sessions would talk about mobility between two technologies. So we will talk more about that in another session. But the basic idea is that we have to do mapping between the bearers and PDB context in legacy technology. Now we have got a couple of questions, so let's address those before we move on to the next topic, mobile terminated fallback. Yeah, so TeamZ, UMTS GSM, we have the concept of TeamZ. So instead of IMZ, which is our original identity for the subscriber, we allocate TeamZ. So TeamZ has been there from the beginning in UMTS GSM. Now I have also started seeing something like that in 1X also, in one of the standard documents. But yeah, originally that concept came from UMTS GSM. Who maps LAI to TA? MME would need to do that mapping. MME need to do the mapping. And now another question, is, do we need the MSC server to talk to HSS in addition to HLR? Now, if you have regular circuit switch system, then our MSC typically talks to HLR. So that interface, that should be good enough for taking care of registration process. Okay, so if the operator wants to do that, that is possible. MSC server, what is this exactly? Oh, MSC is your MSC server. This is basically UMTS terminology. In release 4 of UMTS, we broke MSC into two pieces. One MSC server, another one media gateway. Okay, so MSC server only takes care of all setup signaling, so basically signaling, and the media gateway lets traffic pass through. So voice frames, our speech frames, are not traveling through MSC server, they travel through media gateway. So we separated control plane from the user or traffic plane, and that's why the term MSC server. So in 1X we just call it MSC, but in UMTS, beginning with release 4, we separate MSC server from the circuit switch media gateway. And someone has just a comment on the MSC server, the word server, but as I said, it's in UMTS world. So 1X, it is just regular MSC. We have some mobility related question. Oh, so let's say we have the user going from one location area identifier to another location area identifier. So how does the MSC know the location? A very good point, very good point. When we support the CS fallback, then we have to be a little more careful about designing the boundaries of location area, tracking area. Okay, so let's say location area X and Y. Okay. So we want to make sure that our tracking area is designed well. So when the user goes from one tracking area to another, it will do tracking area update, and then MME knows about tracking area and new location area. Okay, so this is important. Otherwise, if you just have, let's say, one big tracking area, so this is problematic. Let's say tracking area A, and we have location area X, location area Y, and if MSC1 is here taking care of this MSC2, then we have problem, because if we have registered the UE here as part of the attach operation, Then MSC1 has that information, right? But in Z X and MME alpha. But if the user goes to another location area, then MME doesn't know that because it's same tracking area, right? So we want to avoid this kind of situation. Okay. So when you are CS fallback, then we have additional constraints that we need to be aware of. Right? You want to make sure that when the user is going from one tracking area to another, then we have cleaner solution. So this will work because here MSC1, MSC2. So you have to be just more careful on how you design the boundaries of location area, tracking area. So this would be okay. We just need to plan for boundaries. Oh, a lot of questions suddenly came. Let's address the questions. In case there is no packet switch handover, how do we process suspension of PS? Oh, basically, when the user goes to CS, then MME knows. So let me go back to that picture where we have call flow. So when the UE goes to the legacy technology, then MME is aware of that here at this point. So MME knows the user has already gone into the legacy technology area. So in that case, MME will suspend the bearers. So it will work with other nodes, SGW, etc., E node B, to suspend the bearers. So we will have to release the S1 user plane radio bearer, but we will keep S5. I mean, we will note, we will observe the channel endpoints, the QoS. We will remember all those things. We make a note of that. So the data would no longer flow. We only store the information about the bearers. So you can reactivate quickly. So at this point, MME knows. And because of that, we are able to suspend the packet switch session. Okay. So whatever data is coming will be lost. Okay. Only after you come back to LT and reactivate those bearers, then only you can do the data transfer. So you can resume data transfer only after you come back to LT. Okay, so this is how we will process. So suspension will occur here. There is some call flow with 1x CS. Let's see how much time we have. So I will at least draw on the journal. Okay, and if we have more time, then I will talk about that. But at least I will give you a reference. So I will try to show you. Okay, let's see how much progress we make. Another question, LT standards, automatic periodic registration. Oh, see, the problem is the following. See, our UE is on one specific technology at a time, right? So if the UE is on LT carrier frequency, it is just doing periodic tracking area update, things like that. Then it is not jumping to another technology. Okay. If U is on LT, it will stay on LT unless LT signal becomes very weak and we have to reselect to another technology. That is different. But as long as we have good LTE signal, the UE stays on LTE signal. So it will do periodic update, periodic registration with MME. Okay, because it is periodic tracking area update. So we do have periodic tracking area update, but it is with a specific technology. Okay, then so it's little different from 1X and 1X video interworking. Okay, this is LT and UMTS type interworking. So the UE has to get on the CS network to let the CS network know of its new location. Change in the UE location, that is effectively controlled by MME. So when the UE is moving across some geographic area, then the MME is aware of UE location at the tracking area level, and accordingly we can update the MSCs if required. Maybe when MME is changing, then the new MME will inform the MSC server that the UE is in specific area. So MME and MSC interactions, the SGS interface will take care of the mobility. So UE itself does not need to leave LT and go to CS technology for location area update. We can stay, indeed UE will stay on LT even when we have CS fallback. Okay. The CS core network update, that is taken care of through MME MSC interaction. For CS fallback, the requirement is that at a given location, both LTE, EUTRAN, and legacy radio access network both need to be available. Then only CS fallback is possible. If you are in an area where only LT is available and no legacy technology, or vice versa, you are in only legacy technology and there is no LT, then you cannot do CS fallback. CS fallback means that right now you are on LT. Only to make or receive voice call, you go to an alternative 2G, 3G technology, and then you come back to LT for data. So both technologies must be overlapping, must be available in that specific location. Thank you for your questions. Let's go to the next topic, mobile terminated CS fallback. So here, because of the combined attached operation in the past, the MSC knows about this specific MME, that is the SGS interface, that MME number 10, for example, is responsible for the UE. So when someone tries to contact us, the MSC would send a page message to the MME, and the MME would ask e-note this in a given tracking area so that we can send a page message. Now there is very nice feature available. Along with the page message, we indicate who is calling. So if the user does not want to respond to that specific call, then we can reject. Yes, fallback, reject. So if the user does not want to take the call, why unnecessarily go to all these processes? Okay? That will be waste of network resources. On the other hand, if the user accepts that call, then we will continue spending our time and effort on setting up the call. So that is the idea behind having the identity of the caller. But the message itself is still the same, extended service request, which is the same as what UE did for mobile originated call, same message. So now we say, let's say accept, so we are accepting the call, and now the MME will inform the eNode B that this UE wants to make a CS fallback call and help the UE. So UE would get some kind of instructions through RRC connection reconfiguration to make measurements of another technology, but that is optional. But if eNode B does that, then the UE will send measurement report. Inside the report, we will say, let's say, UMTS primary scrambling code. We got number 200. So now we know this is the best cell to do the handover to. If we have support for packet switch handover, we will do that. Otherwise, we will just make the dial dormant. The command that we sent is handover from AUTRA, mobility from AUTRA. That is the command that we sent to the UE. The page response itself is coming to the legacy technology. So the page message we got from LT, air interface. But the response to the page message is sent to the target technology itself, the legacy technology. This is for legacy. And then we get that all the way to the MSC here and do the normal call setup. So now in that case, once the call is set up, it is going between UE and legacy radio network and the MSC. If you have done the packet switch handover, then the data would be flowing between UE and the legacy radio network and the SGSN. And then depending on the architecture, it would be talking to PGW or GGSN. So that's dependent on the architecture. In one of the future sessions, we will talk about that. Mobility across two technologies. So what is the basic difference between the mobile originated and mobile terminated? The main difference is the page message here in case of mobile terminated. But other than that, the basic message is still the extended service request, whether it is mobile originated or mobile terminated, same service, extended service request. Okay. So we looked at the combined attach, so that is after power up. So now MSC server, MME know about each other. We looked at how to do mobile originated call, how to do mobile terminated call. So that is all about CS fallback. Now if we have time toward the end, we would talk about the 1X CS fallback as well. At least I will give you the main concept, okay, at the minimum. Okay, let's have a quick poll here. I will give you a couple of minutes. 30 more seconds. Okay, let's look at the results. 80% got it right. So CS fallback. So we do have connection between the MME and the MSC server, that is the SGS interface. Now, after power up, what we need to do is combined attach. Combined attach means attaching to the LTE network and also attaching to the legacy CS network. So we have to do combined attach if we support CS fallback, because otherwise we cannot even use SGS interface. Right? We have to do combined attach. That's how the legacy network becomes aware of UE's existence. Okay, a couple of questions. Oh, someone needs clarity. Let's take care of those questions. MSC only keeps track of MME. Yes, exactly correct. MSC just knows who the MME is, right? For that UE, which MME is taking care of the UE. So MSC doesn't worry about location, area, etc. MME identity is known to the MSC. That's it. MSC doesn't worry about anything else. That is correct. That is correct. So MME gets the page message, and then MME will figure out where to send the page because it knows about the tracking area. That is correct. Your understanding is correct. So from the MME's perspective, whenever it gets a page message for a CS call, it will send that page from all the eNode bits in a specific tracking area. Yes, that is correct. Okay. So for CS fallback, the only thing we need to know is, okay, a page message needs to be sent. So MSC only needs to know who the MME is for that UE. That's good enough. Another question. Cost of RF block as a percentage of overall UE cost. I'm sorry, I do not know the cost. The only thing I have heard is it is expensive. That's why you do not see these kind of UEs, because it is very expensive. So unfortunately, I do not know the dollar amount or percentage cost, but it is significant. That's for sure. Otherwise, you would have seen a lot of hybrid devices with multiple RF chains and baseband chains. So it is indeed expensive. That's for sure. But I do not know the percentage cost. But it is significant. That deters the vendors from supporting dual transceivers, full-fledged transceivers. So if someone else is aware of that, please let us know. Okay. Now there is one sort of side topic, but it is important. SMS. We normally consider these SMS as a circuit switch service, right? Because that's what we have been doing in legacy 2G, 3G technology. However, yesterday we talked about SMS over IP. So we can put SMS inside a SIP message. And the name of that SIP request message is message. The so-called SIP message includes SMS. But that's one way. Now, if you want to use some other alternative, then we have that available now with SGS interface. So here is the idea. Let's say we want to send SMS. Then if there is no IMS, no problem, no IP-based SMS, we can still send and receive SMS by using these interfaces between MME and the MSC server. So if the UE is in the idle mode, it has to exit idle mode and enter the connected mode. That is a requirement. So this LTE UE needs to get out of the idle. So now basically we have RRC connection and we have all the other links, S1 user plane, S5, S8, everything is there now. Once the connection is already there, once the bearers are set up, then the SMS would be sent through non-access datum signaling. And non-access datum signaling connection is between UE and what? So here is my question. Non-access datum NAS signaling connection is between UE and what? Who is the other end of NAS connection? Okay, I see some answers. MME, perfect, yes, MME. So we have now the UE including the SMS message inside some NAS message, and I will give you the exact name later in the next couple of minutes. But basically, we do have the NAS connection between UE and the MME. So we can put SMS inside a NAS message. So when the MME opens up that message, it will find that, oh, there is this SMS inside, and it will then forward that to the legacy circuit switch network, more specifically MSA server. So in a non-IP, non-IMS way of supporting of supporting SMS, we are relying on two things. We are using the NAS signaling connection between UE and the MME, and we are using the SGS interface. So those are the two key components. Those two together help us send SMS and receive SMS. So we have a variety of scenarios that support it. So if the UE is in the idle mode, again, UE originated, UE terminated, UE is in the connected mode, then much simpler, because we do not need to send service request. Service request is only to exit idle mode and to enter connected mode. But if you already have the connection, if you already have the bearers and NAS connection, even simpler, you can directly put SMS inside some NAS message. Very, very simple. So that is the basic idea. Now let me show you the call flow that will give you exact message name. Okay. Now, prerequisites. So we have done the attach operation in the past. If the UE is in the idle mode, then the UE would do service request so that we can set up the bearer, we can set up the NAS signaling connection, etc. So that's all taken care of. Now the UE wants to send SMS. So it would say, UE originated. So UE wants to send SMS. So it will send a NAS message called uplink NAS transport. Now, that is actual name of the message, next message. Okay. Now, over the air, it is a RRC message. Okay. And then S1EP message between E node B and the MME. So here it will be uplink, downlink, information transfer. And here it will be nest transport. Uplink, downlink, nest transport. Okay. So it would be S1 AP message over the S1 MME interface. But over the air interface, it is placed inside some RRC message, uplink, downlink, information transfer. So for uplink, it is uplink information transfer. For downlink, it will be downlink information transfer. So this is right now uplink. It will be uplink information transfer, and that would be carrying nest message, and inside that nest message we have actual SMS. So now SMS has arrived at the MME. MME would use the SGS interface with the MSE to send uplink unit data message that carries SMS, and the MSE works with legacy service network. So for SMS, interworking MSE, and this is the SMS service center. So that message is forwarded to the SMS service center. The idea behind this is we can have many MSCs talking to the same interworking MSC to simplify the implementation, and then we have connectivity with SMS service center. So now SMS has found its way to the service center, and it will deliver to the destination, wherever the destination is. Now, once you get SMS here, the MSC will send acknowledgement of SMS reception, that I got SMS, that's the message that will find this way. Okay. So we just tell the UE that we have received your SMS. We may or may not have sent that all the way to the destination, but at least we got SMS from the UE. That is the acknowledgement. So that acknowledgement is coming like that. Now, once the service center, SMS center has delivered the SMS to the destination, it will create a delivery report. This message sent, message delivered. That will go all the way to the UE. Okay. So those are the message names: downlink unit data for SGS, and downlink nest transport, and RRC, downlink information transfer containing delivery report. And we have to now send the acknowledgement for the delivery report. So that is inside the uplink nest transfer. That will go here. So now MSC knows that, okay, the delivery report has been successfully received by the UE. Now, after some time, we would release the bearers if there is no more activity. Now, once you send one SMS, you should wait for some time before releasing the bearers, because maybe there would be another SMS, so there would be some kind of timer. And if that timer expires, then we would start releasing the bearers, etc. But we should keep that at least for some more time, because there may be multiple SMS. So here is an example where we have UE originated SMS. The UE terminated SMS, in that case, what is happening is the service center is sending SMS to the gateway, SMS gateway MSC, and gateway MSC needs to figure out which MSC should I forward SMS to. So it will use the help of HLR to figure out the MSC, whoever is in charge of that UE, and once it figures out, oh, this is the MSC, it will forward the SMS to that specific MSC. MSC uses the SGS interface to send a page message. Now, if the UE is in the idle mode, right, then the page message would be sent. We will have service request. This is the UE in the idle mode. Okay, so in that case, we are sending that page message through RRC paging. We have to exit the idle mode. So here we are entering the connected mode. So idle to the connected mode transition, that is taken care of by service request procedure. So let's say we are now connected, and now the actual SMS would be coming to the MME. So that's the actual SMS now, because the connections are all there. So UE gets the SMS, downlink NAS transport message, uplink NAS transport, that is acknowledgement to the SMS. That will find its way to the MSC. And once it is delivered, the delivery report is sent. This is act to the SMS, and then after some time, the delivery report again we have to send back to the destination. So there's the delivery report, and once that is done, the acknowledgement to the delivery report, that is sent like this. If there is no more SMS for certain time period, then we would release the bearers and other resources. So in summary, we have support for UE originated, UE terminated SMS. UE may be in the idle mode, may be in the connected mode. All those scenarios are supported. We have a couple of questions. Yeah, so if the UE is already in the connected mode, then no need to send a page message. Okay, we can use the existing NAS connection. So as an example, we can directly go to this kind of step, downlink NAS transport or uplink NAS transport, like that. Downlink, uplink NAS transport to take care of the SMS. The service request procedure, okay, and paging, we use that here is a very important point. Okay, only to exit idle mode and enter connected mode. That's it. So if we are already connected, then we already have NAS connection, we already have the bearers, everything is there. So we can directly start using RRC, uplink, downlink, information transfer, and uplink, downlink, NAS transport. We can directly start using those connections. So no need for so-called paging, no paging. UE opens up a NAS message, and inside that NAS message, we find SMS. Very simple. Very simple. The whole SMS process is in LT. Yeah, that is the benefit. Absolutely correct. So if you look at the call flow, right, the SMS itself, right, is going over LTR interface. We are using LTE core network, right? And so we are not accessing legacy radio network at all. So we are staying on LTE interface, and we are using the NAS connection with the MME to take care of SMS. So yes, that's a very good point. We never leave LTE radio access. We stay with LTE radio access, and we use NAS connection and SGS interface to take care of SMS. So that is a good point. A couple of other things. Someone has a comment. Let's address that. Legacy core is used, but radio networks are not used. That is correct. That is correct. We are using legacy core network, MSC, for example, but no radio access network used. Correct. 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 Minor comment. Service center. Yeah, service center. It is not single carrier. Yes, that's correct. Oh, it looks like our acronym has only single carrier for SC. Oh, okay. Correct. So we are talking about this SMS service center. Okay. We are not talking about single carrier. Correct. So thanks for your comment for the acronym. Okay. So that is SMS. Okay, let's have a quick poll here. I will give you a couple of minutes. Uh, 30 more seconds. Please participate in the poll. Very easy. Think and click. Thinking is a prerequisite. In the meantime, let's answer this question. What are NAS messages and how are they different from other messages? Okay, let me draw a picture, okay, once we are done with the poll. 10 seconds to go. To earn full credit for the session, you need to participate in the poll. Right now we have, let's say 30, so slightly over 50% participation. So please participate. Web browsing, Google, BlackBerry, Blueberry, iPhone, iPad not allowed. Okay, I see some more folks are participating. Very good. 10 seconds. Okay, let's look at the results. 75% got it right. See, SGS interface. That is between MME and the MSC. Now, the actual SMS is placed inside some nest message. So nest message we are indeed using. So we cannot avoid a nest message if we are not using IP. There are two ways of receiving SMS. We can use IMS, IP. That's what we discussed yesterday. And today we talked about how to use SMS with nest signaling and SDS interface. So we need both nest signaling and SDS to be able to support SMS in case of a non-IP based solution. Now let's answer this question. What are these so-called nest messages and how they are different from other messages? So let me draw a picture. As they say, a picture is worth 1,000 words. So instead of saying 1,000 words, let me draw a picture. So signaling messages, many kinds of signaling messages. So between the E node B and the UE, the signaling messages are called RRC signaling messages. Radio resource control. Now, between the E node B and MME, that's S1 APA message. The interface is called S1 MME. The interface here is signaling radio bearer. So if UE wants to send a message to the MME or vice versa, this is called NAS signaling connection. Okay. So those are the LTE signaling messages. Okay. So over the air, it is RRC connection. So as a simple example, let's say I have this RRC message, so-called uplink or downlink information transfer. That is the name of an RRC message. So when E node B and UE want to talk to each other, they will use RRC signaling messages such as this. So that is defined in this specification. That's the grade scheme. Okay. Now what kind of NAS signaling messages can we send? So you can look at this specification, 24.301. Okay. So an example would be something like this is the NAS message. So UE and the MME can send uplink, downlink, NAS transport type message. So that is let's say a NAS message, but that NAS message is between UE and MME. So over there, you have to put that in some RRC message. Okay. So over there, it is RRC signaling, and between UE and MME, they are exchanging those NAS messages. But they will be encapsulated, they will be placed inside an RRC message. So hopefully that is clear. If you need any further information or clarification, let me know. If I do not get any follow-up question, I will assume that you are okay. So if you are not okay, please ask follow-up questions. Okay. Let's see, it's almost break time. Let's have a 10-minute break. And then once we come back, we'll take care of the rest of the material. And I would at least give you conceptual view of through audio bridge. Please feel free to do that now. *7, unmute. *6 mute. I will wait for few seconds. To Audio Bridge, please continue submitting questions through Q&A box. Okay. We have this vision. It's a grand vision, okay, little bit futuristic for now. ISC, IMS service continuity. So we'll look at the concept here, and then we'll take a specific example, one specific implementation, which is SRVCC. But what is this ISC? Here is the idea. Let's say we have communication between two endpoints. And the media is traveling between those two endpoints through the IP network. But after some time, we want to move media to some other device. So in that case, we will use the help of some application server, service centralization and continuity server, to help us move the media to another device. So we can move the media to, let's say, high definition TV. So now the media is flowing between the UE and some other device, not the UE, but some other device such as TV. So we can choose what medium we want to get on what device. Something on UE, something on iPad, something on TV screen, things like that. That is the grand vision. Okay. So at the same time, we may have multiple types of media on multiple devices. So initially, perhaps we have the voice and the video flowing directly between two UEs like that. And after some time, when let's say this other user wants to share high definition video, so we can use the help of application server, and the application server will help us move the video from UE to the high definition TV. So we are using this kind of application server to decide which media should go where. So that is the idea. So at the same time, we are using multiple devices. So if you look here, UE, we are using voice, and the high definition TV, we are watching a video. So multiple access for multiple types of media. That is the idea. So in the cellular world, we can have voice, for example, on legacy circuit switch technology, could be GSM 1X, and high-speed data, we can use LTE. So in that case, we have even possibility of having multiple transceivers. Right? The cost of the device would be higher, but we can use one technology for voice call, another technology for data at the same time. So that is the grand vision that we have, and to support that kind of functionality, we will rely upon the IMS, and one example is some kind of application server sitting inside the IMS network. Then to help IMS network, we could have the circuit switch core network that is enhanced for IMS centralized services, or we can use a legacy core network, and in that case we can upgrade the UE. So it is up to the operator what kind of solution we want to use. Do we want to upgrade the network only, UE only, or you want to upgrade both the UE and the network? So there are a lot of possibilities, and we may have single radio or dual radio, but this is sort of little bit futuristic. It will be several years before we can really implement this. But the idea is that any technology for any given medium. That is the idea. Okay, let's have a very simple question on ISC. I will give you a minute to answer this question. So we'll spend the remaining time on SRVCC, and toward the end I would summarize 1x circuit switch fallback. Right now our participation is less than 50%, so I'm waiting for you to submit your answers. One more minute. Ten seconds to go. Okay, so most of you got it right. It is true. IMS service continuity means we can direct media to some other device, right? Multiple options. Okay, so now what is SRVCC? So as we mentioned earlier, when we are in the LT coverage area, then we will use voice or IP. And voice or LT, that's the solution we have chosen, that is based on IMS. However, when we go outside LT coverage area, there is no LT available here in that specific geographic area. So we have to do handover. This is a single radio device, single radio. So at any given instant, it is either on LT or some non-LT system. It cannot be on both systems exactly at the same time. So we have to do handover because there is no LT available. And now, when you do the handover, it's called SRVCC, single radio voice call continuity. You are able to continue your voice call even as you go into another technology area. IMS is still the anchor. IMS will help us do this kind of handover. Now, currently, in the standard, this is one-way handover from LTE to legacy technology. In future, we will have bidirectional handover. But right now, the assumption is that once we go to CS technology, the user stays with CS and finishes up the voice call, then user can come back to LT. Because LT will be in some pockets, legacy technology will be everywhere. So once you go to legacy technology, you can stay on legacy until the call is over. That is the idea. That should be the most common scenario. So one-way handover from LTE to legacy technology, SRVCC, in the initial version of the standard. Okay. So let's look at the architecture that helps us implement SRVCC. Here is the UE. So when we set up a call in LTE, then we are using the help of the radio network, the core network, then we use the IMS network. So basically we have proxy, call session control function, PCC architecture is there. So we have now set up the voice or IP call with the LTE system. When IMS network knows that we are in LTE. After some time, the user keeps moving away from the LTE coverage area. So then we would have to do handover. And when we do the handover, we have to move the voice call because the legacy technology is all circuit switch voice. So we have to do the handover from packet switch voice to circuit switch voice. And to help us do that, we have this new interface. SV is the new interface. And the MSC and the MME will work together so that we can do signaling between the two entities to take care of the handover. IMS network will act as an anchor. So it knows that now we have moved into legacy area. So we can maintain the session, the voice or IP into CS call conversion that is facilitated by IMS. So in future we can go back and forth between two technologies with IMS facilitating this kind of handover. Here we are showing release 4 architecture of UMTS. So it means that MSC has two parts, server and the gateway. Server is doing the signaling related to the call, and media gateway takes care of the real voice traffic. So if you are talking to, let's say, someone using landline phone, then the actual voice traffic is traveling this way. Okay. Signaling would be like that. Okay, that is signaling. Signaling MSC server comes into the picture, or traffic circuits which media gateway comes into the picture. So SV is your new interface that helps us communicate between two networks, legacy MSC and LTE MME. Let's take a look at call flow, how we can take care of the call. It is actually handover. We have one question. Oh, okay. Along with the voice, can we do data? Sure, no problem. So you can do the data also with the legacy system, no problem. Yes, that is supported. So just like what we do in circuit switch fallback, we can move the data to legacy packet switch core network as well. So yes, we support that in the standard. Yes. Okay. So right now, our voice or IP call is ongoing. We have bearers, established. We have end-to-end EPS bearer between the UE and the PGW, and IP packets are flowing, voice or IP packets. So let's say some kind of IP phone or whatever, could be landline phone, either way. But we are talking to some other endpoint, and as far as LT is concerned, voice or IP packets are traveling between UE and the PGW. That is going on. Oh, someone made a comment, not simultaneously. So there are several possibilities. The standard is extremely flexible. So in general, if you're talking, let's say, between UMTS and LT, then the standard has packet switch handover defined. So your voice or IP becomes a CS call, and your other data bearers become PDP context for packet switch coordinate. So in that case, the UMTS example, we have simultaneous voice and data, because in UMTS, right from day one in release 99, we have had the capability of simultaneous voice and data. The voice is through CS core network, data through packet switch core network, SGSN, GGSN, and so on. So if we are doing SRVCC between LT and UMTS, no problem. We can do simultaneous voice and data. It's all UMTS. Now, if you are talking about GSM, GPRS edge, then it is tricky because you cannot do simultaneous voice and data. So GSM, if you here, voice is more important. So when you go to GSM, you have your voice with you, but the data sort of, you have to keep the bearers dormant. That would be the most common scenario. So if you go to older technologies, 2G, 2.5G, then data is essentially gone. They are bearers, and those bearers are dormant. But if you're talking about 3G UMTS, yes, then you can have simultaneous voice and data. Now, if you think of 1X RTT, then in 1X RTT itself, in the current commercial deployments, we have either voice or data. So 1X does not have simultaneous voice and data in the commercial deployments, typically. So if you do SRVCC with 1X, then you will have voice call transferred to 1X. So voice or IP in LT becomes a circuit switch voice call in 1X. So then the data would be typically sort of lost. Bearers will be dormant. However, I have seen recently that at least in the standard, we have lot of new features coming up. There is so-called enhanced circuit switch fallback. So in these kind of situations, we can do voice with 1X, and we can do data with EVTO. So maybe hybrid devices with more than one transceivers, maybe they would come to the market sooner than later, and then you can really do voice data. So in the standard, there is a lot of work. I have seen some standards where there's some documents where we have this kind of handover mentioned. So standard is indeed working on that, but in terms of real world implementation, it would be initially only 1X circuit switch call. So your data would probably just be dormant unless we have proprietary solutions where you have dual transceivers. Then it's a different story. Then a voice will be through 1x, and data would be just simultaneously but through another independent baseband processing block and RF processing block. That would be like initially proprietary implementation by the UE. That is always possible. But from the standards perspective, initially 1x voice and no data. That would be the common scenario. Now we have one more question. Oh, two questions. Voice codec conversion, legacy. Free operation. AMR adaptation. Yeah. That's a very good point about codecs. We have voice over LT recommending, actually requiring AMR speech codec. But in 1x we would be using EVRC. So we would have basically our device with multiple codecs. So when we are on LT, we will use AMR speech codec. That is correct. And when we go to 1x, regular 1x, we will use EVRC. So that would be common scenario. Yeah, that's true. Now, so we do not do any conversion. So there is not some box just doing the conversion. We can just start using EVRC. Because regular 1x device would support EVRC anyway. So that should not be a problem. Another question is, after handover, voice would be handled by the MSN. What is the role of IMS Cloud after handover? Oh, okay. So IMS is just helping us move the session from IP domain to the CS domain, and in future vice versa. So it is only facilitating that, because what would happen is when we are talking voice or IP in LTE, then IMS has your information. However, when you go to legacy technology, you cannot just abandon, you cannot just give up your session, and IMS needs to be aware of that. And indeed, let's talk about the call flow, and then we'll be able to understand a little better. Okay, the role of IMS. So in this example, right now, voice or IP is ongoing with the LTE system. The UE sends a measurement report that says the physical cell ID, let's say for LTE cell number 10 is, let's say, quite weak, minus 95 dBm, something like that. There's the RSRP for that cell ID, RSRP, reference signal receive power, and we would say EC or N naught, or primary scrambling code in UMTS. Number 10 is, let's say, minus 7 dB. So very good UMTS quality and poor quality coming from LTE set. So E node B now makes the handover decision that this UE is better off going to the UMTS technology, because the UMTS is able to give better quality. So that's the reason this E node B is requesting the MME to do handover. And we say that this would be SRVCC handover because we do have some voice call ongoing, and now we need to do handover to legacy technology. So it is an example where we need to do SRVCC. MME would have to work with legacy technology, in this case MSC server, that is the interface, that we need to do the handover. So it will make a request for resources. MSC will work with its own RNC to reserve the resources. Now, MME knows about the UE capabilities and network capabilities. So it knows that, okay, this guy is going to UMTS and we can do voice and data simultaneously, concurrently in UMTS. So then it could split the voice and non-voice bearers. The voice bearer would correspond to the circuit switch resource request, and for the data packet switch EPS bearer, it would have to work with the SDSN, and SDSN would have to ask RNC if resources are available. So now MME is playing a very important role. Depending on the capabilities of the UE and so on, it has to make that decision. If we are just talking about 1X, then our data would basically disappear unless we go back to the LT system in few minutes. So that's the step number 4 and 5. Making a request for resources to support the circuit switch voice call and packet switch handover. Once the resources are available and reserved, then the MME gets the acknowledgement from SDSN and MSC that the resource reservation is fine. MSC, now here you will see the role played by IMS. So now the MME has got the radio resource reservation acknowledgement. In the meantime, MSC would contact the IMS network. Okay. There are application servers here. Okay. And SCC, Service Continuity, Centralization and Continuity server, that server would get this message that, oh, we need to transfer the session. Because so far, the application server was in the loop. It was processing all the SIP signaling messages. Now, if the UE goes away to legacy technology and there is no SIP signaling, then we suddenly lose the track of the session. Right? So that is the reason that MSC is now informing the IMS network that, oh, we need to transfer the session from IMS IP domain into the CS domain. So that's what is happening here. We will have some session transfer number, some kind of number. It is like phone number that we are transferring, and SR is the SRVCC. So session transfer number for SRVCC, that is identity. So it is like phone number. Okay? So every UE that is capable of SRVCC would get some kind of phone number, and that is the identity of that session. Because IMS network, our application server, may have thousands and thousands of UEs engaged in voice or IP calls. So IMS needs to know which of those calls we are transferring. That is the reason we have to include this kind of identity. And then IMS will work with MSC to transfer the session. So now the call control signaling, okay, is taken care of as far as the handover is concerned. In the meantime, we have to tell the UE to go to the target technology. And to help us do that, the MME would send handover command to the eNode B, and the eNode B sends mobility from EUTRA command, RRC message, to the UE, indicating the target technology. So in this case, we are indicating that UE should contact a specific cell, UMTS primary stumbling code 10, At this point, the UE leaves LTR interface. So you can do voice everything up to this point because it's all LT. So data is ongoing. But now UE is on another technology, maybe UMTS technology. So UE does the handover and it will start communicating with legacy system. As far as voice is concerned, the voice will be going between UE and RNC and media gateway, circuit switch media gateway, and so on. If we have data, then data would be between UE and RNC and SGSN, and SGSN and either PGW or GGSN, depending on the architecture. Okay. So that is for data. If we are able to do packet switch handover. So standard supports it, but it depends on vendor implementation and also depends on operator configuration. Okay, let's have a poll here. So it looks like we have some time left, so we should be able to cover 1x circuit switch fallback. So that is good news. So I will give you a couple of minutes for you to complete these polls. Please participate in the poll. Thirty seconds to go. And this is an open book exam, so don't worry, you can look at the PDF file that you have. I have indirectly given you the answer. Okay. We have not directly given you the answer to this question. Okay, when we say which node makes the handover decision, so that node decides whether UE should stay with LTE cell or UE should go to some other technology. That is the handover decision. That should the UE stay with the LTE cell or should the UE go to another technology cell sector. So who makes that decision? If you look at the call flow, you will get some additional ideas. Let me give you another hint. The node that makes handover decision processes measurement reports from the UE. I will repeat my hint. The node that makes the handover decision does so by processing measurement reports received from the UE. Who processes measurement reports from the UE? Okay, let's look at the results. So before I gave the hint, I had 50% correct answer. And after I gave the hint, I have almost 75%. So my hints are probably good. They do help you. Very good. So let's look at that coil flow diagram. This is the diagram. See, the UE sends measurement reports to the E node B. And the E node B has the handover algorithm. So that E node B now decides should the UE stay with LTE or go to some other technology, a specific cell or sector. Okay. So handover algorithm is inside the E node B. Okay, that's it. And let me just make sure there are no outstanding questions. Oh yeah, there is one thing here. Dual transfer mode is not allowed into the CS handover processed anyway. Yeah, so dual transfer mode, yeah, we do not use typically in commercial networks. So then we will lose CS handover. Yes, then we will lose CS handover. Correct. Because voice, we place a lot of emphasis on voice, right? We do not want to lose voice calls. Data probably we can restart our Internet Explorer window or something like that. But voice we want to continue. So yes, the CS handover would be ongoing. Yes. Okay. So very good. We still have some time. That is good because I had got some requests regarding 1X circuit switch fallback. So let me open up some document from the standard, and then we will talk about that. Give me a few seconds. Okay, I need to open up some document. Okay, so the document that we will use is 23272. That is for circuit switch fallback. Maybe I can reduce a little so you have better visibility. Okay. Appendix B. Okay. So first let me give you a brief overview of the interworking architecture. Okay. So we have basically 1X interworking solution. This is the key node to support interworking between 1X and LTE. It is called 1X circuit switch interworking solution. Now, that talks to the regular MSC, 1X MSC via A1 interface, and it talks to the MME via S102. So, an MME that supports 1X circuit switch fallback needs to support S102 interface. Very, very important. Now, the beauty of interworking solution here is that this interworking solution appears like BSC, like R and C, to the MSC. So from MSC's perspective, it talks to regular 1X BSC here, and it talks to another BSC, and that BSC happens to be the interworking solution. So we are able to reuse all the signaling messages that are between the BSC and the MSC, okay, or the RNC and the MSC. So what interworking solution needs to do is whatever messages it gets from the MME over S102, it will translate those into something that MSC understands. And similarly, when it gets something from MSC, then it will translate that into something that MME understands. So that is a very nice, elegant solution to the interworking problem. So 1X interworking solution is basically doing the mapping between the 1X messages that are typically on the BSC MSC interface, and that message, those messages are received over S102. That's the idea. Now, how do we use that interface? So let's talk about two main aspects of interworking. Okay. So first is pre-registration. That is 1X circuit switch pre-registration. So we have basically done the attach operation after power up here. Okay. The UE has done power up attach operation, and once attach operation is done, this is the regular attach. Okay, do not worry about combined attach. This is regular attach operation. So we have the barriers, S1 MME interface, radio, everything is there. And then in step number 2, UE decides to register with 1X circuit switch network. Now, how do we make that decision as a UE? Very simple. eNode B is sending out so-called system information block. I think it is number 8. So inside that system information block number 8, it would say whether 1X registration should be done or not. So let's say that flag is turned on. So the network in that cell supports pre-registration with 1X. So once that flag is turned on, the UE knows that, oh, I am supposed to do registration with 1X circuit switch system because I am capable of CS fallback. So let me do that. So if the UE is in the idle mode, then it will do service request. If the UE is already connected, very simple. It will just send the registration request inside an RRC message, uplink information transfer over the S1M interface. The eNode B is sending uplink S1 CDMA 2000 tunneling message, that is S1 AP message. So this registration request is encapsulated here, encapsulated 4B, and now look at the message between MME and the interworking solution. This is S102 interface. This is the new interface that MME needs to support. So MME will use S102 direct transfer message to forward the registration request to the interworking solution. 1X in circuit switch interworking solution appears like just another BSC to the MSC. So then we do the location update. Once we tell the MSC, here is your user, then the acknowledgement, the response will go back all the way to the UE. So in future, when MSC wants to send a page message, now it knows which interworking solution is responsible for the UE. From the MSC's perspective, it does not know that it is talking to interworking solution. It thinks that it is talking to some BSC, 1X BSC, because that same standard interface here. Okay, so we have tried to minimize the impact on existing networks. So in summary, after the regular attach operation in LTE, the UE does the pre-registration, and as part of the pre-registration, the 1X MSC becomes aware of the UE existence, that this UE is inside specific BSC, which is nothing but interworking solution. Okay, so now pre-registration has been taken care of. Now we can make a call, we can receive a call using circuit switch fallback approach. So let me give you an example of how that happens. Okay, so we have mobile originated, we have mobile terminated, maybe terminated little more interesting. Yeah, let's go to terminated. Okay. So someone is trying to reach the UE, okay, voice call. Someone is trying to make a voice call with the UE. So MSC is sending a page message to the interworking solution here, and interworking solution knows the MME that is in charge of that UE. It will send a page message over the S102 interface, and then we may need to wake up the UE and set up all the bearers so that UE enters the connected mode. There is the service request and paging process. But if the UE is already connected, no problem. We can just put that page message inside existing S1 MME connection. So S1 EP message is downlink CDMA 2000 tunneling, RRC message, downlink information transfer. So this RRC message, this is S1 AP message, S1 application protocol. Those protocol messages are encapsulating page message from 1X. And if we have to do CS fallback, and in this case we are doing CS fallback, so then we are sending extended service request to the MME here. And inside that we will say that we want to use CS fallback. So anytime the UE needs to do CS fallback for mobile originated, mobile terminated call, does not matter. It will always send extended service request message. Inside that, there is an indication for CS fallback. So now that goes to the MME. MME says, okay, let's modify the UE context, request the EU tran that optionally do the measurements. So eNode B may request the UE to make measurements of 1X RTT sectors, P and offset. And accordingly, we have better visibility of which 1X RTT sector is the best candidate for this kind of handover. The RRC connection is released with redirection to the CS fallback with 1X RTT. Release request goes from eNode B to the MME. Now we need to suspend our EPS bearers. That is the reason the MME is sending the suspend request to the serving gateway. So the serving gateway sends the acknowledgement. So now our bearers become dormant. Okay. So in future, when the UE comes back, we can reactivate those bearers. That is the idea. However, right now, since we are going to 1X RTT, we will release the UE context. So radio network forgets about us, no knowledge of the UE. In the EU tran, the page response is now directly going to the 1X system. So from UE, it will go to the MSC. Now that is through the 1X RTT radio network. So here we have already left LTE EU tran, and we have accessed 1X RTT radio access network, and that's the page response. going here. Once the page response is received by MSC, you go ahead and do the regular call setup. So hopefully you got a very good understanding of how we can support circuits which fall back using 1X RTT. Okay, let's see, there is at least one question. It's about mobility. And again, the document here is 23 272 if you want more details. Okay, so the question is on mobility. If CS these different frequencies, some cells are not one-to-one overlay. Yes. Okay, here is the basic idea. We need to go to a different technology. From LT, we need to go to 1X or UMTS. So as long as we tell the UE which cell to go to, we are okay, because the UE will access that specific cell recommended by the EU tran. Now, to facilitate determination of the best possible cell sector in the target technology, we have measurements. So eNode B can optionally ask UE to make measurements. So it does not matter whether we have 1-to-1 overlay or 1-to-5 or 5-to-1, it does not matter. The UE will provide the measurements, and inside the measurement we'll say, oh, PN offset number 100 is the best EC or I naught. Or in UMTS primary scaling code number 20, it has the best EC or I naught. So we will have visibility of the radio environment. Okay. And now, if you do not do any such measurements, let's say it is optional, so we are lazy, let's say, we do not do that, then we have to just take the best guess. So in a specific LTE cell, if we are in LTE cell physical cell ID 20, then we have to have some kind of static mapping with UMTS or 1X RTT cell or sector. Now, in that case, the performance may be slightly worse because, as you have pointed out, maybe it is not one-to-one overlay. So then we may not be in the best possible cell. We would have to probably do the handover almost immediately. But that's the trade-off that we have to settle on. So either do the measurements that will give you very accurate view of the radio environment, or if you do not want to do that, then you are just making a guess on the best possible cell. Okay. So if you have measurements, you do not have to worry about this overlay 1-to-1 versus something else. So I recommend having measurements. It will increase the delay a little, but at least you will have better chance of succeeding. Oh, couple of more questions. The call setup is using the carrier in the redirection. Yeah, so we have to indicate the UE, what carrier frequency, right? Because hopefully the UE has been measuring that technology, so hopefully it can quickly resynchronize, and we have to identify the target cell or sector, PN offset, primary scaling code, whatever the case may be. Yes, so we have to indicate that, correct. We have to indicate the target sector, target cell. And of course that means frequency has to be part of that identity of that sector or cell is also present. Another question. After you terminate the call in legacy network, how do we go back to the LTE? Oh, very, very simple. Let's say our UE is now on legacy technology. So we have done the CS fallback or whatever, and now we are talking on the legacy technology. Now the voice call is over. Once the voice call is over, and assume that there is no data, okay, so we enter the idle dormant mode. In the dormant idle mode, the UE keeps looking for better technology. So it will detect some LTE cell that is giving much better quality than legacy technology. So then it will do the cell reselection to the LTE technology, and then we can resume our data bearers in LTE. So that would be the most common way, where we have idle mode cell reselection from legacy technology to LTE. If we are already sort of talking, maybe we have even done the packet switch handover, so that our voice is with legacy, our data, packet switch data is with legacy. Then what do we do? Then as part of the measurement control, the legacy RNC would dictate the UE that please make measurements of LTE, and when LTE is stronger, send me a report. So then in the connected mode in legacy technology, especially UMTS, the UE makes measurements of LTE. It reports LTE measurement to the legacy RNC. That 3G RNC would then make a decision. Oh, LTE is able to give better quality. Ask the UE to go to LTE. Send handover command. Then we will do the handover to LTE. So either way, could be idle mode cell reselection or could be connected mode handover. Both are supported by the standard. Thank you for your question. Let's summarize what we covered today. So today our focus was on circuit switch fallback SRVCC, two mechanisms that are related to voice. In general, you could have voice over LTE. We use IMS and IP for that. We may have circuit switch fallback. So we disappear from LTE air interface. We fall back to legacy circuit switch technology. Once the voice call is over, we can go back to LTE, that is CS fallback. We have a vision, ISC, IMS, service continuity. So maybe for one service, we will use one technology, voice, CS, and for data, maybe LTE. So different types of applications, we can use different technologies perhaps. One special case that we will see being used in practice in the short-term future is SRVCC, single radio, voice call continuity. That is a specific case. This is more practical. ISC would take some time before it becomes a reality. Circuit switch fallback, we do not need IMS. However, the other two approaches, ISC or SRVCC, we do rely upon the IMS network to help us with call transfer. Circuit switch fallback, basically in a given specific area, LT is available and another technology is available. So we must have overlap, radio coverage overlap. So in that case, let's say we are doing data on LTE and we want to make or receive voice call, then we leave LTE.
Nishith, we're not hearing you anymore.
Oh, how about now?
Oh, yes, better.
Oh, okay. Yeah, by mistake I pressed the mute button.
Okay.
Okay. Yeah, keeping the Instagram muted is not a good idea. Okay. ISC, IMS service continuity, one technology, one service, maybe another access technology, another service. So that will see the light of the day little later, not now, but at least SRVCC is quite practical, available today. So in that case, when we leave the LTE coverage area, go into a legacy technology area, then we do the handover. So from voice over IP in LTE, then we go to circuit switch call in legacy technology. And in that case, we use the help of IMS network as the anchor. IMS will facilitate such a handover from LTE to legacy technology. Now, initially, it is one-way handover from LTE to legacy CS technology. In future, we will have bidirectional handover, but right now it is one-way handover from LTE to legacy. And the hope is that we will finish the call in legacy technology, and then user can go back to LTE. That's what I have for today's session. Thank you for your participation, for your questions. Anything else for me? Any questions through the audio bridge?
Remember that *7 to unmute your line.
Okay, so Dan, feel free to send the evaluation form to the students. I'm here for a few more minutes, so feel free to type your question or use the audio bridge. And we will see you talk to you in another session Monday.
Great. Well, thanks so much, Nishith, again for an informative discussion. I'm glad you were able to have time to go through the additional example at the end. I have put up the survey on the screen, so if everybody could please take the time to complete the survey. You do need to be in full screen, and if you are having difficulties seeing it, you can close the live meeting interface and reopen it, and that usually helps. If that's still you are not able to see it, then go ahead and send me an IM and I'll send you the direct link. So again, thanks so much for taking the time to complete the survey. I will be sending out for those on live meeting the annotated PowerPoint as well as the journal or whiteboard notes that Nishith created during today's presentation.
We got one question. What is blind redirection? Good question. Blind. We are making decision without